Okay.
Today is 2019, February 26th. Okay. I am HinChi Lei. I teach in National Central University Department of Civil Engineering. In this video, I want to explain the MATLAB program I have written recently. The name of the program called ASICAE. This name comes from the abbreviation of this statement: automatic searcher of the intersection of circular of earthquake. I use this program and the functions to find out the intersection of circular of earthquake. Okay. Here, let me. Actually, I have published a paper recently. In that paper, I didn't put the detail of the program, so I create this video to explain the detail of the main program. Here, ASICAE. Let me follow my paper. In the third line, here, third line, this statement and this statement and this statement help us to plot the map of Taiwan, and also this is the data file for the earthquake event happened around Taiwan in the past 40 years. This data file comes from the Central Weather Bureau of Taiwan. And also from 4th line to 7th line, we are searching for research for the events happened before this date. 1983, take it as an example. 1983, July 1st. We want to search for the event 3 years before this date. Okay, we use this line to do this job. And also, the event we are searching for have a magnitude greater than this parameter. This parameter here we set 3.09. So all the event we are searching for we have the magnitudes greater than 3.09. Then the longitude of the events are ranged from 118 to 123. The latitude of the events we are searching for range between 21 to 26. This the magnitude and longitude for the events happen around Taiwan. Okay. Okay. And in the 10th line, we set two parameters. These two parameters is related to the precision, the accuracy of the circular arc of earthquake we are drawing. Okay, this concept will be explained in the paper, so I don't explain it in detail. These two parameters have been shown up in the paper. Okay, so you can find out the corresponding places to understand the meaning of these two parameters. Okay. Also, we have three roots: 1 root, 2 root, 3 root. Okay, we have 2 roots for I from 1 to n minus 2, j from j plus 1, I plus 1 to n minus 1, k from j plus 1 to n. N is the what is n? N is the length. Yes, the length of the event. Okay, the events we have searched. So these are 3 roots. Let me show you. Okay, so we have 1, 2, 3. 3 roots. Okay. So what we are doing using these 3 roots? Let me show you. We use these 3 roots to look for different sets different set of 3 different events. Okay, one set with 3 events. We have different set because we have a lot of events to deal with. We take it as different set. Every set have 3 events only. Okay. What this for? Because for every 3 events, we can draw a circle. Okay. Because we can flip every 3 event on the map by a circle. So we use this loop to help us. And also we use these statements to require that the arc length we are looking for cannot be too short. Okay. The explanation of these 2 statements have been written in the paper. Okay. And also here we use the function fc to what? To find out the circle connecting the 3 events, and the information of circle will be the output. This xc, yc will be the center coordinates of the center of the circle. R is the radius of the circle. Theta is a vector. It has 2 values. Theta 1 and theta 2 corresponding to the angle of the 2 endpoints of the circular arc. And then after we have drawn the circle, we want to check whether the circle is really a circular arc we are looking for. What do you mean? We have 3 events inside a circle, but we are not sure these 3 events are distributed uniformly. Okay, we have 1, 2, 3 uniformly. 1, 2, 3 uniformly. These 3 events may be like this: 1, 2, 3. Okay, 1, 2, 3. So these 3 events are not distributed uniformly. In this case, we don't take it as our circular arc of earthquake. We are looking for the circular arc with 3 uniformly distributed events. Okay, so we use this function to help us to check this. And also we use this function to check another thing, because along the circular arc of earthquake we are looking for, we have at least 5 events, not 3 events. So we started with 3 events to draw a circle. On this circle we have 3 events, and we need another 2 to get 5 events. Okay, and we use this function to look for another 2 events to form a circular arc with 5 events, and these 5 events are distributed uniformly along the arc. Okay, so we use this function to do this job. Once we get this, once we implement this, we can find out whether such kind of arc exists or not. Okay, once we implement this, we can check this. And also here, in this case, we use another function, f theta to plot arc. What I mean, this is very clear. The name of the function tells us that we use this file to prepare the data for us to plot the arc. Okay, and then here we are also using this statement to plot the 5 spatial points along the circular arc. Okay, because along each circular arc we have 5 uniformly distributed spatial points. Around each spatial point there is at least 1 event around each spatial point. So we use this statement. The red I represent red. Red has a hexagram to represent 1 spatial point. Each one spatial point. We use this to do this job. Okay, let me implement this this program. Before we implement it, be very sure that you understand that the event we are looking for are the events with magnitude or larger than or larger than or equal to this parameter, and this parameter is set to 5.09 here. Okay. We implement it. Okay. Wait for the result. Yes. Very nice result. We implement this program. We get a two circular arc, one circular arc, another circular arc, and along each circular arc we have 5 uniform events. The blue star stands for events. 1, 2, 3, 4, 5 for this arc. For this circular arc, 1, 2, 3, 4, 5. Okay, 5 events uniformly distributed. And for this one, 1, 2, 3, 4, 5. Okay, so for each circular arc we have 5 uniformly distributed spatial points, and along each spatial point there is at least one event. Okay, earthquake event. Okay, so this is one circular and this is another circular, and these two circular arcs intersect each other to give us the intersection. By the term intersection, it means that the totality of these two arcs. Okay, we have two intersection point in this case, and also we want to claim that this is the strongest circular. This is the strongest intersection we can find, because if we look for the event even stronger, then there will be no intersection. Let us show you. Here, the key point here, if we modify this parameter to a stronger value like 5.1, then we have no intersection anymore. And we change it to 5.1, and then we implement it. See, one circular arc of earthquake have been cancelled, so there is no intersection. So if we modify the magnitude of the event we are looking for even higher, then even this circular arc will disappear. For example, we look for 6.5. So the events, all the events we look for are with the magnitude greater than 6.5. I don't think there are many events like this. Only one event. So with one event, how can you can find out any circular arc with 5 uniformly distributed events along the arc? No way. Okay. So not saying the intersection, we have even no any single circular arc. So in this way, we turn it to 5.1 again, 5.1 again, and then implement it. We have only one arc, and then we get it down to 5.09 here. Then we begin to get the intersection. So this is the intersection. We call it the strongest intersection we can find. Okay, 5.09 here, 5.09. Okay, we implement. Yes. So this tell us that this is the strongest intersection. So I want to show you the function here. For example, we have some function here. FC, FPR, F502, F502 points in art, and also other functions. The data to plot the art or something like this. Let me show you quickly. Here in this one, this is FC, huh? This is the function FC, okay? And this is function FD. This is function FD. And this is the function PR. Okay, this is the function PR, okay? And this is the function function free equal, okay? And this is the function function f data to plot art, and this is the function f follow 2 points in art, okay? And FC, this is function FC. I think I have mentioned this before. I'm not very sure. That's okay. So anyway, this is the functions I have used to help us to implement the job. And once we get into the main program to set up this is the main program here. I use the condensed form, make it more precise, okay, more concise, and set this magnitude, this parameter, and then implement it. We can get the result. Okay, finally, let me show you the paper I will publish recently in National Cheng Kung University. I think coming this March 20 something. I'm not very sure. March 19 or 20 or March 20 something. Okay. So next month. Let me show you the paper here. Okay. This is the first page of the paper. This is the first page of the paper. The second page. Let me turn on the light. Okay, this is the second page of the paper. And this is the third page of the paper. This paper will be published in the UP Forum. They call it the UP Forum, held in next month, March, late March. Okay, in National Cheng Kung University in Thailand. This is the first section of this paper. And next page. See here, this is the figure we have been generated before. I also put this figure on the paper. Okay, this is the fourth section of the paper, and this is another page. And also, there are totally 14 to 15 pages, okay? And this is the main result in the table. So do it more carefully, okay? And also, next page, we have the major figures. Major figures. Major figures. this is the conclusion and discussion. So finally, we get some major conclusion here. First, second, and third, fourth, and fifth. These are the major conclusions. Finally, this is the acknowledgement, I think, for my sons, my brother, my sister, my wife, and Professor Jian Ziqian, Chen Jianzhi, and also my students in National Central University, because they help me a lot. And also this is the references. Okay, that's it. This is the paper in which this program are explained and also applied to search for the circular, the strongest intersection of circular art of earthquake. And also we have some important results. If you are interested in this, you can